Hi, and welcome to the video on how to draw Lewis dot structures of covalent molecules. This is example 1, hydrochloric acid, or HCl. Now, in your notes, you actually have these examples all done out, and the steps are written on the side. I've just basically modified the steps in more user-friendly language, but it's the same steps that you have in the PDF of your notes. So what do I mean by drawing a Lewis dot structure of a covalent molecule like HCl, also known as hydrochloric acid? When I say draw a Lewis dot structure, can you, from a chemical formula like this, create a structure of the molecule that shows how the atoms are connected, the order of bonds, are they connected by single, double, or triple bonds, and where the lone pairs are? And that's what Lewis dot structure does. It basically shows you where all the valence electrons go, if they go in bonds, what type of bonds, and lone pairs. So let's get started by following these steps. So if you're given a chemical formula like HCl, the first step says to count the total number of valence electrons from all the atoms. So this molecule is made up of two atoms, hydrogen and chlorine. And if I want to count the total number of valence electrons, remember I need to go back to my periodic table. Because the periodic table, there's a pattern with valence electrons. The number of valence electrons sort of matches the group that it's in. So for example, elements in group 1 have 1 valence electron. Elements in group 2 have 2 valence electrons, so like beryllium, magnesium would have 2, and so on. We skip our transition metals, go straight over to group 13, which starts with boron. This one has 3, and 4, 5, 6, 7, and 8 for most of these. These have 8. Of course, helium just has 2. Okay, so to get the total number of valence electrons, I find these elements in the periodic table and then figure out how many valence electrons they have and then add them together. So here's hydrogen. It has 1 valence electron, so that's 1. And chlorine is in group 17. It has 7 valence electrons, so that's 7. So my total number of valence electron here will be 8 valence electron. All right, the next step says to construct a skeletal structure. So what exactly is that? A skeletal structure is basically a structure where the atoms are all connected to typically one central atom, so there'll be one atom in the center, and then all the other atoms are connected to it through single bonds, okay? So that's what a skeletal structure is. Now, in this case, we only have 2 atoms, so our skeletal structure is easy. We don't have to actually choose a central atom, but in the other examples, you will. So for us, since we only have 2 atoms, they can only be connected to each other, and we're going to do that through a single bond. So your skeletal structure should only have single bonds on it, no double bonds, no lone pairs. The next step says to arrange the remaining electrons. So every atom has 8 electrons around it. Remember, 8 electrons corresponds to what's called an octet. And the exception, of course, would be hydrogen. Hydrogen is in period 1. Elements in period 1, their valence shell is the first shell, which can only fit 2 electrons. So hydrogen typically wants to have just 2 electrons around it, which corresponds to 1 bond or a lone pair. And if it's in a molecule, it has to be 1 bond, right? Okay, so, and they're saying that we want to have every element, except for, of course, hydrogen, to have 8 electrons around it, using the remaining electrons. So when we say remaining electrons, we need to go back to our total and figure out how much we've actually used. Remember that a bond is made up of 2 electrons, okay? So 1 bond is made up of 2 electrons. That means that of the 8 valence electrons we started with, we've already used 2. So that means that we have 6 remaining, okay? So this is our remaining number of valence electrons. So what I'm going to do is I'm going to redraw it over here. Here's my skeletal structure. I need to arrange those 6 remaining so that everything gets an octet. Now, hydrogen is good. It already has its 1 bond. But chlorine isn't, so I need to give it an octet. So to do that, I'm going to arrange the 1, 2, 3, 4, 5, 6 electrons around it. Now we're going to check to make sure it actually has an octet. And that's sort of what the next step is talking about, checking to see if it has an octet. And I'll do that up here. All right, so how do we check to see if it has an octet? It's real simple. In a covalent bond, the electrons in the bonds are shared by both atoms, so both atoms sort of own it at the same time. It's sort of like if you have a sibling and you both have a dog, it's not like you own half the dog and your sibling owns half the dog. You both have one dog. And so that's sort of what's happening here. So when we're counting the electrons around the chlorine, we're going to count the electrons in the bonds that are attached to the chlorine as 2 belonging to the chlorine. So we can go around counting. This chlorine Cl has 2, 4, 6, 8 electrons around it. It has an octet. Now, the hydrogen is good with one bond because remember it's in period 1, so it's happy with one bond or a pair of electrons on it, so that's good. All right, so this structure looks good. Now, the last step at the bottom is about formal charges. We're not really going to get into that here, but I will link some resources if you want to see how to calculate formal charges. Those are important when you get to AP chemistry, if you take AP chemistry or college chemistry, and they're super important if you're going into pre-med and you have to take organic chemistry or you major in chemistry. You'll definitely want to know this stuff, so I'll link a resource to that. All right, that's it for example 1. This is how we go from a chemical formula to our Lewis dot structures.